Hello, everyone. We are happy that you are all here. Welcome to our talk. My name is Černý. This is my colleague Matus Marhefka.
Hello.
We work at Red Hat. We work in a RHEL security compliance team. And today we are excited to talk about security compliance and bootable containers. So let's start with the security compliance. What we mean by security compliance in our talk. We will not talk about vulnerabilities or CVEs, bugs in code, and things like that. Instead, we will talk about configuration compliance of operating system. A lot of users, a lot of customers need to configure their system to meet some security standards, to meet some security requirements. This is important for customers from banking, healthcare, governments. Yeah, for example, if a bank needs to process card payments, they need to comply with a standard called PCI-DSS, which stands for Payment Card Industry Data Security Standard. And that tells them how exactly the system, the whole machine needs to be configured to be able to run and to be allowed to be used. So on Linux, in Red Hat Enterprise Linux, this configuration compliance is implemented and supported by some tools, namely OpenSCAP scanner, and the security content provided by the Compliance as Code project. And those are projects that we with Matus work on. And those tools allow users to automate the security compliance, to perform some scans to verify that they are configured in line with the security standards, and also to remediate the system, which means to change the configuration of the system to comply with all those requirements and standards. Now, the second part of the title of our presentation, and that's bootable containers. Who of you have heard about bootable containers? Raise your hands now. Wow, I can see a lot of hands. So let me just quickly review what bootable containers are. Yeah, so those are standard Linux containers. They are compliant with OCA, so it's really a container that you are familiar with. But those containers contain Linux kernel. That's a new thing because up until now, you were always told that container is something that doesn't contain a Linux kernel. And now we have containers that contain Linux kernel. And they also contain bootloader and drivers and some other tools like bootc. Yeah? And in fact, it's a complete operating system image. Yeah? So you can use bootable containers as operating system images to, like, instead of ISO images, you can ship everything in a container image. And you can use existing tools, like container tools, Podman, Docker, container registries, CI/CD pipelines to work with bootable containers. Therefore, you can manage the operating system images using Podman. And the bootable containers are used to ship so-called image mode operating systems or immutable operating systems, which means that everything comes in a container image, in a bootable container image. A system, a virtual machine is deployed, and then the system, the running system is sort of immutable. That means a lot of paths on the system are immutable as you can see on the image, yeah, for example, /user or /lib, those are read-only paths. Yeah, so image mode operating systems, they usually contain the bootc tool that you can use to manage the system and to update the system, to get a new version of the image from a container registry and then perform an update to the new version of the image. And the updates are atomic and automated. Yeah, so once there is a new version of the image available, the system will automatically download the image. It will set things up, and then you will just reboot, and you will reboot to the new version of the image, and or to the new version of the system. And if this new version, for some reason, doesn't work well, then you can easily roll back. Yeah, you just reboot again, and during the boot, you choose the old version. Yeah, there are some caveats. If you remember that I told you that a lot of parts of the system are read-only and immutable, that means that you basically cannot install new packages using DNF on a running system. You instead, you are supposed to rebuild the container image, for example, using Podman, and then deploy or update it using the bootc tool. Yeah. So the image mode operating system kind of integrate with the container tools and with the CI/CD pipelines that can work with containers.
Okay, so bootable containers are really exciting new technology. And if you think about it, they actually bring many benefits for security compliance of the operating systems. The biggest one is that they allow you to use just Containerfile and Podman to build and deploy a full-blown hardened operating system. And with this approach, we do all the configuration compliance configuration only once when we build the container image. And we don't need to do it on every single machine which we manage in our fleet. And we also get the security compliance baked in from the beginning of life cycle of our operating system configuration and deployment. Then once we have a hardened container image, we can deploy it into image mode, and we get a system which is compliant from the very first boot. We don't need to do anything else afterwards. And we have possibility in image mode of the atomic updates, as Jan mentioned, which is easy for us then to make updates of the running system to the newer version of the security policy. We just pull the new image and we switch to it easily. Now we can briefly look how we implemented it how we implemented security compliance in OpenSCAP using OpenSCAP ecosystem with bootable containers. So we introduced a new utility which is called OSCAP-IM. The shortcut is for image mode, and this one should only be used in a container file when we build the hardened image. And inside it integrates the security compliance tools which we mentioned. So it uses OpenSCAP and security content from SCAP security guide package, and all is updated to work in bootable containers, so it should be transparent for the users. Once we boot such a container image, we switch back to using OSCAP, which should be familiar for people who know the OpenSCAP ecosystem. So it's the same as on a so-called package mode or standard deployment of the systems. So brief overview of the workflow. So step one, you have a container file. You put all the configuration for your operating system inside, and at the end you run the OSCAP-IM command. you specify the security policy which you want to use for the hardening. Step 2, you build the image, and during the build, all the configuration, including security compliance, is applied to the image, and then you end up with a hardened image, which in step 3 you can deploy. You can deploy either on virtual machines or on bare metal systems. And for this purpose, you can use one of these 3 tools. So the first one is Bootable Image Builder. This allows you to convert the hardened bootable container image into various other formats, for example, into ISOs or into QCOW2, which can be then run as a virtual machine. Second option is to use Anaconda Kickstart, where there is a new verb called OS3 container, which you can, where you can specify the container image which you want to install to the system. And the third one is the nice new utility called Podman Bootable, which allows you to quickly run the container image as a virtual machine on your laptop, and it's more suited for experimentation or for some testing. And now is demo time.
Yeah, the demo time. Let's show the workflow in practice. So we will show you how to build a Red Hat Enterprise Linux 10 bootable container image that will be hardened with a CIS profile. CIS stands for Center for Internet Security, and that's one of the very popular profiles that, or policies that customers use to harden their systems. Yeah? So we will have a very simple container file. You can see it on the screen. We will use Red Hat Enterprise Linux 10 bootable container image as a base image. Then in the container file, we will install the OpenSCAP scanner and security content, which kind of provides this CIS profile. And the third step, that's the most important step, is that we will run the OSCAP im. That's the utility that will perform the hardening. That's the utility that will reconfigure everything in the image to change it to kind of be compliant with what the CIS requires. So let's start. This is the container file. And we will run podman build using this container file. Yeah, so now it installs the OpenSCAP and SCAP security guys. And now we will run the OSCAP im utility with the CIS profile. So again, it installs some packages because those packages are required by the CIS profile to be present on the system, on the target system. And now it runs rule by rule. Yeah, the policy consists of some rules, and it kind of tries to remediate, tries to apply the configuration on the image. Yeah. We are still watching the podman build output, yeah? So this is happening inside the container build environment. And we got a container image, a bootable container image. Second step, we will deploy the bootable container image as a virtual machine. To do that, we will use the Bootable Image Builder that can easily convert the bootable container image to a virtual machine. It will simply take the image that we have built and it will produce a QCOW2, and now we will start the virtual machine from that QCOW2. Yeah? So the virtual machine is starting. We will get its IP address, and we can SSH to it and use the bootc command to verify that it was created from the bootable container image that we have built. And you can see it at the top of the screen. Yeah, the image used is the CIS latest container image. Now, we will perform a verification scan, yeah, to kind of verify that our VM, our virtual machine, is compliant with the CIS profile. And for that, you can use the OSCAP utility as you would do on a normal package mode system. Yeah, I think some of you are familiar with this command. It's in RHEL for years. Yeah, so it again goes rule by rule, and now it just reads, yeah, it verifies. It will produce some report shortly. Yeah, we can see that there are a couple of rules passing. We can now download the report from the VM to our laptop to show it in the Firefox browser. So let's open it. And you can see that it's a report from OpenSCAP. It uses the CIS profile. Yeah, all the tools were kind of adjusted to work with bootable containers, but they are old tools. Yeah, and you can see that we are passing a lot of rules, actually majority of them. Yeah, there are some of the rules that are still like work in progress or are known issues that we will fix shortly, but overall we get pretty good compliance score, yeah, and we can say that the virtual machine that we deployed is kind of meets the requirements of the CIS policy.
Okay, now we have a running hardened image mode system. But there are still some things which we need to keep in mind. So namely, these are day-to operations because, as we mentioned, most of the system is immutable, but there are still some parts which are writable, namely /etc, where you store system configuration, and that one still can be modified when we run the system. So you still should do periodical verification scans that you are still compliant with the security policy, and there are no breakages. Second thing is that /var partition is actually not updated when we do update of the image mode system to the newer version of the container. There are multiple reasons for that. For example, user home directories are symlinks to /var, so there can be some persistent data. And some security policies, as currently implemented, they modify files in a /var, which means there can be some conflicts if we update the image to a newer policy and the policy somehow changes. So this is something to keep in mind. And the third thing is the immutability itself. Even though it's a great thing, it helps with security and makes system more secure. But you need to keep in mind that if you need to do some major modifications to the system, you will be forced to actually go back to your container file, do it there, rebuild, and redeploy. And here we have some known issues or gaps. For example, many security policies require the system to be partitioned in some particular way because of some requirements. And we cannot really do that automatically in our implementation because we do all the, we do all the hardening in the container build time. So, and we don't have the information about the final system where the container image will be deployed. So we cannot really do that automatically. Second thing is that most of the security policies are not really tailored for the image mode. They were implemented with the standard package mode in mind. So there are some gaps and possibilities for improvements and introduction of new requirements which would be tailored specifically for the image mode systems. And the third thing is that you need to put the hardening actually as the last step in your container file. And this is to prevent breakages in security policy, because your custom configuration might, if you do hardening as first step and then your configuration, it might happen that your configuration is in conflict with the hardening and you might end up with a system which is not fully compliant. And here we have like some full picture how you can actually work with image mode systems. So in the yellow box, we have systems which are deployed in image mode. So these are systems which you have, for example, hardened to some security policy, and you configure automated updates for them using bootc utility. And on the left side, in the blue box, there is development CI/CD environment which you can have, which basically what it does, it pulls the base image from the container registry. It can build the hardened image, somehow test it, and then push it back into the container registry. And now we can have some hypothetical situation. For example, your deployed systems are affected by a security vulnerability, and you want to update and fix it. So you usually, what you do, you rely on the software vendor, which, for example, can be Red Hat, who publishes those RPMs with the fixes and also updates the new container-based image with those RPMs and pushes them into the container registry. And you can have your development environment configured in a way that it detects this, that there is a new version of the base image. It pulls the base image. It applies your custom configuration for your deployment, plus it also includes the OSCAP command, which does the security hardening. You build the container image. You can additionally test it, so you make sure that everything works as expected, and then you push it into the container registry. And that's it from your side. Because deployed systems, they're configured with the automated atomic updates. So what will happen, all the systems will detect that there is a new version of the container image in the container registry. And they will pull it and switch to it and reboot. And basically you have all the systems fixed. And you can do basically the same, for example, if there is a new version of the operating system, or if we release a new version of SCAP security guides with updated security policy. And this is our last slide with some resources. First one is linked to the official documentation where you can find more details about the hardening and bootable containers. And the second one is the link to the hands-on demo where you can try exactly what we did here in our demo. So you can build your own hardened container image and deploy it on your machine as a virtual machine. Yeah, and you can use the QR code, which should bring you there. And that's it. Thank you for your attention, and feel free to ask any questions.
So, questions there?
I have one question is just out of curiosity, because you mentioned SCAP, and it's just a policy, right? So, like, which profiles you have is actually those profiles that you want. Mainly just aware about the door issue. So, like, is there any profiles already created for SCAP?
Yes, so the question was about if we are aware that SCAP is just a policy and there are different profiles. I think, yeah, we are aware of it. We work with that for a long time. So actually, SCAP is a standard. It's a language that allows you to express those different profiles. So there can be multiple profiles for different customers for different purposes. And we in Red Hat Enterprise Linux, we ship those profiles implemented in this SCAP language or SCAP languages, and we ship it in RHEL. and all those profiles are already ready for the bootable containers. Yeah.
Yeah, but my question was about yours. Do you know, like, if there are any profiles already created? Do you know what the story is?
No, I'm not familiar.
So it's a digital operation resilience stack. It's from European Union. So it's starting from here. And there is a couple of documents and policies saying like how you should implement your IT system to be compliant. And it's not like, okay, it's, you know, already been published, so maybe there are also more profiles created for that.
Yeah, so I will just repeat the question. It was about the European Resiliency Act, that there are some profiles and those are, I guess, mandatory for some customers. Yeah, so unfortunately, we don't have this. We don't have this implemented. Yeah, it is not available. Yeah, I think it could be possible to do something, but it isn't currently in our plans. Here.
Would actually possible to run this on Kubernetes? Would see containers run on Kubernetes?
So the question was if it is possible to run the bootc containers on Kubernetes. Yeah. So the workflow that we presented, or the scenario that we presented, is meant mainly for like edge devices or for virtual machine. I think in Kubernetes there are like similar concepts like CoreOS and things like that. For example, yeah, we work differently in OpenShift or in Kubernetes. For example, in OpenShift there is a compliance operator that also uses SCAP and OpenSCAP inside, but uses kind of a different approach. Here. Yes, so the question was how the implementations of profiles are different in a package mode and image mode. Yeah, so we tried to reuse as much as possible. So I would say like, I don't know, 80% of it is the same. And there are some differences. Some things are different, done in a different way. Yeah, so kind of, for example, some of the remediations can detect that they are running inside the Podman build environment, and they configured the system differently or using different tools than they would do in a package mode environment, but kind of they try to achieve the same outcome. Yeah. Does that answer your question?
Bootable containers are, I understand what's the advantages compared to VMs, but should I use bootable containers instead of regular containers? Can I do the same hardening for regular containers and, for example, running on Kubernetes?
So the question was if I should use bootable containers instead of regular containers, and also if I can harden the classic containers using this mode. Yeah, so I would say that they have different use cases. The bootable containers are meant to ship either the base operating system or some image for, as I said, a VM or a device, edge device, some small device, whereas the classic containers are meant to be like for Kubernetes or applications for those microservices. You can have a container that contains a database and things like that. So the approach would be different. I would say that currently we don't provide hardening for the classic containers, as they kind of, I would say, differ a lot from classic operating system. Yeah, they don't contain the kernel, and the policies or the standards requirements that our customers use are usually written for the classic systems or VMs in mind. Yeah. So they would like kind of apply to the host or to the Kubernetes master instead of the individual containers. Yeah, Matus, if you can add something or...
Yeah, basically, as Jan said, there are different things. Bootable containers you use for deploying on like virtual machines or standard systems, and then you can run on top of them the standard application containers.
Yeah, I would say like you can run OpenSCAP and you can run the hardening on the classic containers, but what you get is that a lot of the rules will not be applicable. For example, we have a lot of rules around systemd services, and in classic containers you don't run systemd, you don't run systemd services in the typical use case. Yeah. Any other there?
I was wondering, do you know if Bootable containers support ignition?
So the question was if the Bootable containers support ignition. I don't know. Do you know?
I don't know, unfortunately.
For example, when I think about compliance and virtual machine, it comes to my mind federated contents of your register, for instance, against the satellite or domain controller, right? Like in runtime, when the VM is provisioned, you do stuff like joining if real, right? Since it's immutable, you never know what's going to happen when you do something in runtime, right? Because this configuration, like enrollment, was not built in. So I was wondering if there is something like ignition or if it supports some way to run a script after it's been provisioned, like Cloudinit or...
Yeah, so the question was about if there is some tool how to configure easily like authentication, IPA services after the deployment. Yeah. So the basic idea behind the bootable containers is that you do everything during the container build, during the podman build. Yeah. So I guess you can run some Ansible playbook as a part of your container file. But you can also have something as a part of the deployment, yeah, as we had in the demo, the Bootable image builder. So there are like those image builder customizations that you can use, for example, to define partitions. But yeah, the problem really is that once the system is deployed and running, a lot of, or a large part of the system is immutable and is not designed to be changed, yeah. So it really depends on the configuration. Like, for example, if you change something in etc, you can apply it after it's running, yeah. You know, like, yeah, but the general idea is really to do everything at the beginning during the image build process. There?
So my question is that can we add PCI devices, let's say, in general OS, right? So we add Matrocast code, and if we can do with the Bootable containers as well, because it's an operating system, right? So can we add PCI devices and how the compliance impact, if it is possible?
So the question was whether we can add PCI devices and hardware support during the container build. Like I would say yes, it's possible. You can, in the container file, you can add some, for example, I guess kernel modules. You can have additional configuration. Yes, so it really can conflict with the configuration. For example, if you have some USB devices, I think you need to kind of add some allow policy for USB guard if the security policy requires USB guard running. Yeah, so that's just an example. Yeah, it really depends on the specific policy and on the specific use case. Yeah, so and the specific hardware. Yeah, so.
So for example, let's take an example of SRIO devices, right, in the edge computing. So for dedicated, let's say, if it is running in OpenShift, or let's say it's using OpenShift as a application in the background, right? And we deployed a boot container for that particular specific application. For example, application is running on bootc background. So is it possible that for, let's say, if we have networking SRIO devices, right, SRIO functions, so is there anything that we can do right now, or is it in work or something that you are aware of?
Yeah, so the question was about specific like networking devices, whether we can like configure them and recommend something. Yeah, and I really don't know. Yeah, we don't work on this level. Yeah, and I guess we are out of time. Yeah, yeah. So thank you very much.